Are we on? Yeah, hear me? Good to go? Cool. Uh, hey, camera folks, sorry, I do like to walk around a bit, so I'll apologize ahead of time if you have to kind of chase me down. Also, super cool, gigantic LED screen, huh? I'm used to like speaking in front of a projector and blocking it, but now this is incredible. And all the dark video game scenes you'll be able to actually see, which is cool. Hey everyone, how's the DevFest been so far? Everyone saw the Scott Hanselman keynote, super amazing, awesome guy. Today we're going to talk about some stuff in accessibility. We're going to talk about gaming. We're going to talk about machine learning and AI and really like a whole lot of different things. There's a little bit of something for everyone. So who here's a gamer? Show me hands for gamers. Oh, a lot of you. How many of you came to the talk because you saw games and you're like, gamer stuff? All right, how many of you saw accessibility and you're like, I want accessibility stuff? How many of you are like, AI, give me all the AI stuff oh, good. All right, so we're gonna focus a little bit more on that towards the end too. But really what I sort of wanted to share in this session is kind of a little bit of a story in product development using AI in different ways, working with people with disabilities and accessibility in general, but specifically in the context of gaming. So, quick sort of background, I'm Alex Dunn. I'm the founder and CEO of a company called Cephable. We do applied AI for accessibility, but you'll find me on the internet as Suave Pirate because Alex Dunn is an extremely ordinary name. And so when I first got into the development community and I was like, okay, I'm gonna like get my name out there, I'm gonna try to be as consistent as possible. Alex Dunn, developer, Alex Dunn does talks, Alex Dunn does tech, and like there's like 1,000 Alex Dunns out there in software engineering. And as a matter of fact, I do a lot of work in the Microsoft stack and on Azure. There are 3 Alex Dunns in the developer team at Microsoft. So I couldn't even be like Alex Dunn who does dev stuff with MicrosoftThings.com. So I took a name generator that I wrote back when I think I was like 11 years old, learning how to code for the first time, a little like console terminal app. And Suave Pirate was it, and I just went, you know what? That works for me. I'm a Microsoft MVP, Game Awards Future Class for the work we do in accessibility and gaming, PubConf champion for those who haven't been to a PubConf, they're amazing. And sort of quick background on the Cephable side of things. Basically, the whole story of what I want to share today is how we got to this point of a platform that lets people play games, control their apps with things that actually just work best for them. And leaning into people's abilities versus trying to conform people to the standard human interface devices and human computer interaction models we have. So things like face expressions and eye gestures and head movements and voice that adapts to them, hands, virtual buttons, really anything. But I really like to start today with a bit of a provocation. A mentor of mine, when I first got into speaking, said, should always start a session with a provocation to provoke the audience into something. And when we talk about accessibility, it's like the easiest thing, and a lot of people sort of hear it all the time. But I come from the perspective of not having spent my entire career in accessibility. I spent my career in machine learning. I spent my career in application development, really in the enterprise space. And I got into accessibility originally back in 2020 to solve a problem for a brother of mine who's 15 years younger than me, who has a disability, and basically saw him trying to play games with his friends and having a hard time with it. So we introduced technology in younger and younger ages. You know, my brother started using a computer in school when he was 7, which is wild because like I didn't get into the computer lab until high school back when I was in school. But kids with technology can do amazing things, and I think there's a purpose to introducing technology at those younger and younger ages. We have kids working on robotics as young as 5 years old now, building Legos and turning them into robotics that actually compete and do things, and then evolving that into things like FIRST robotics, FIRST technical challenges, FIRST robotics challenges, things like that. They also use it to stay connected with people, with their friends, with their fellow classmates, especially through things like COVID, where a lot of education went online. They lost that interaction on the playground, in the classroom, and so technology really became core to how we look at education. So the sort of provocation is, what if a student actually can't access that technology in the same way? When we're accelerating students with technology, it ultimately ends up meaning that we're leaving those students behind at that same accelerated rate. If they're not able to interact with a computer, they're not able to use a Chromebook or one of the Surface Gos that so many of the schools distributed, then they end up facing bigger challenges. Either they're now challenged to overcome it, a teacher or someone or an aide is challenged to overcome it, but really the compounding issues are created from there. And that's what I saw in my brother back when I got started in the accessibility space. Was he had a hard time using a physical controller, a Nintendo Switch controller. He has challenges with dexterity in his hands, basically. And so I went home during Christmas, watched him try to play online, playing Minecraft and Roblox with his friends. Pretty trivial games compared to some of the other stuff we play. and he started to fall behind. And that falling behind started turning into being left out, which was extremely frustrating for me. So some of the other sort of facts, especially in the gaming space, and I'm realizing like standing in the way and the podium is somewhat in the way of this too. So basically, people with disabilities are 1.5 times more likely to consume entertainment through a television. That includes gaming and also like media and streaming. Over 80% of people with disabilities globally, although these stats are coming from the UK, EU, and the US, 80% cite having a challenge with accessibility on just the streaming platform, otherwise just finding technology, finding a movie and using it. 66% feel frustrated, they feel excluded, and ultimately for businesses it means that they basically are leaving billions in revenue on the table. But who do we have to blame for all of this, right? Because we're developers, we build technology. Is it our fault that we create inaccessible experiences, that we've been doing that for decades? And I, for one, can never take blame for anything, so I say no, it's this guy's fault. This is Christopher Latham Scholes, and he is the unfortunate inventor of the QWERTY keyboard, back when we went from typewriters and then adopted the QWERTY keyboard from Mr. Christopher here, and turned that into how we actually interact with technology. The root of how we all have consumed our digital world has always been rooted in things like the keyboard. It's the first actual interaction model we had. Then we introduced the mouse and we introduced the touchscreen, but ultimately it's always been sort of hands-on something. So, not our fault, clearly. But it is something that we can solve because we're technologists, we're developers. So how do we solve it? My solution is with video game violence. So what we're going to sort of share a little bit further ahead is different ways of controlling different technology. Fair warning, there's straight up violence in this. Video game violence is not like real stuff, but there's some like first-person shooter content. I try to minimize it, but it's there. Some role-playing game stuff. Those who came in early might have seen the spoiler of the Elden Ring clip that we have. But we'll also do some live gameplay that won't be violent, so it'll be fun. It might even be a chance for some folks to try it out. How many people have seen this screen in their lives? The gamers over here, I see a few of you. Okay, for those who haven't, this is probably one of the most common screens in role-playing games, specifically in the Dark Souls series. Any Soulsborne people? Yeah, obviously the people that have seen this all the time, but I was wondering if there's someone who's like, no, I've never seen this screen, I've actually never died. I've beaten all of Dark Souls undefeated. 0 death runs, this is so unfamiliar for me. So this is Dark Souls, traditionally held as one of the most challenging games or game series that are out there. And so back in 2019, when I was watching my brother try to play games like Minecraft and Roblox, I was doing speed runs of Dark Souls with my friends in my basement. We made drinking games out of it. Anytime you died, you have to take a drink. And then obviously like we just die more because it just compounds into something that's more difficult. So I thought, well, it's the hardest game. It's also my favorite game. What if I could build an AI that would help play Dark Souls for me? Could I introduce that to someone like my brother who likes simpler games but wants to sort of evolve into a real gamer, a tried and true get good kind of gamer? And if I could solve Dark Souls, then I could really kind of solve anything in gaming accessibility, I think. So I set up some rules. Couldn't actually hack the game, couldn't mod the game. It had to be external to the actual game code. Because there are some bots out there that'll like auto-run the game, and it's just silly. Has to be extendable to other games conceptually, right? So it can't just be for Dark Souls. Has to be usable by people other than me, because I don't identify as someone who has a disability, and I'm building this for people with disabilities. And it has to actually work. So I set out on this path, streaming it on Twitch at the time, trying a whole bunch of different things to build an AI that could do this stuff for me. The first thing I thought, what if I could do image recognition to dodge our attack? AKA, big, scary bad guy, cool hero, us, our little cool guy, big, scary sword being swung at us, get out of the way. And we can automate one of the hardest things in Dark Souls, either parrying or dodge rolling. The problem when we got this running is I did like 3 playthroughs of this game. All this is all like on YouTube, by the way. If you ever want to watch like the most horrendous, like, okay, we're going to record an entire Dark Souls playthrough and then label the data for 24 hours. Super fun live stream. I don't know what I was thinking. The hard part is that Dark Souls is kind of an always dangerous situation. It's not something that you can sort of just Oh, yeah, big scary sword. I should dodge out of the way. Now I'm good. Reset the context, and let's keep going from here. You're kind of just always in danger. And also, I burned an entire GPU on the inference side because I was like, all right, I'm going to run this gigantic image recognition model, this computer vision model that's now running against every frame of my graphics card, while also running the game through the graphics card and running the model inference on the graphics card. And I cooked it, which was an unfortunate like $900 mistake. So I gave up on Dark Souls for a bit. I felt pretty defeated. And this is back in 2020 through COVID, streaming on Twitch, which meant Call of Duty's Warzone was super popular. Anyone play Warzone? Anyone drop in? Yeah, a few of the same gamers, the big gamers. Awesome. So I found myself playing with my friends a lot during COVID. And I thought, well, I yell at this stupid game because I'm so bad at it. Like, what if it actually could do what I did when I yelled at it? So like, serpentine, serpentine, and someone's just shooting at me and I have to get out of the way. So I conceived of this with voice controls, and at the time I was running product and engineering at a company called Voicify. We do speech recognition and conversational AI. So I was like, I'm the guy for this. I can do this. I play games. I do voice stuff. I'm so bad at this game that I need the support to actually play. So I set out this very conceptual diagram here where I was going to have a device, a voice assistant device. I was trying to use something out of the box. In this case, an Echo speaker, an Amazon Echo speaker with Alexa built in. I was going to then have a custom skill set up, which would receive information from Alexa when I talk to it. It would then, from that server, talk over SignalR, over a WebSocket connection, to a Windows app that I had built. And then that would actually try to send inputs to the game using input simulator, stuff like that. Things that aren't allowed on the Windows Store, but things that you can definitely build if you're doing stuff on your own. So here's a little bit about a little bit of what it looked like. I'm going to kind of step out of the way so that you can actually see the ends of the code. Basically, this is a standard ASP.NET Core controller endpoint that we're handling a request from Alexa. So we're using like the Alexa Skills Kit stuff. We're receiving a request, and we had built up this skill so that I could say things like, Alexa, tell the Warzone controller to shoot. Very optimal for gaming, I know. To speak an entire sentence, to click the mouse button, or to press the 4 key, or to reload, or to put on armor, or to crouch, or something like that. So we received that input, and then because I was just building it for myself, over here on this line where I'm talking to SignalR, I just sent it to every client that was listening. So in theory, if you were also running the same client that you had pulled from GitHub or something, you would just start getting my inputs whenever I spoke to my Alexa, and it would start shooting in your game too. It can make like a really cool distributed bot system this way, but you have to speak an entire sentence in order to do anything. So we would then receive this input when we connect on the client side. So this is like a UWP app running on Windows. We connect to the same SignalR client. Whenever we get one of those intents that we just received from Alexa, we then do something like here. We're using an input simulator, and we're pressing a key. In this case, we're either pressing the 4 key or the 0 key, whatever it is. So cool. Tried it all out, opened up Notepad. I'm seeing like 4 being typed. I'm like, I did it, guys. I'm speaking to Alexa, and it's typing in Notepad. Let's hop into the game. So back in Warzone, I would say something like, Alexa, tell the Warzone controller to shoot. But nothing happened. As a matter of fact, fun fact for anyone who games and also uses Visual Studio, don't run a debugger while you're playing just about any game using the Call of Duty game engine, because it will crash Visual Studio and the game. I thought I was getting banned, so like every time I jumped in, I was like, all right, we're in the game. All right, let's go spin up the UWP app and run it locally. We're running the server locally too. Throw up ngrok so we can listen over the tunnel. And like anytime I click debugger, it's like game crash. I'm like, I'm getting banned in Call of Duty for cheating. But no, it turns out some super weird glitch that happened, so you're welcome. All right, so it didn't work in Call of Duty. I thought maybe they've got some like input blocking. Let's go to some other games. Back to Dark Souls, didn't work. Sekiro had just come out recently, didn't work. Someone in chat had suggested this web-based game called Crunker, and that kind of worked, which was interesting. So it's like, all right, I know the inputs are working. Something with the way that game engines actually interact with the input system on the operating system was not allowing it. So we tried a whole bunch of other ways to create inputs, or what I call the other L's that we took. So WPF was send keys instead of the UWP with the input simulator. Didn't work. WinForms, I don't know why I thought that'd be different. It's the same API that it's calling. An extended background task on UWP. I was like, what if it's just like killing the input simulator task when I run the game? Nope. Even setting up a USB over IP didn't work. Ultimately, someone on Twitter who had seen me sharing this like concept in a meetup was like, what if you just like plug in an Arduino that can act as a USB HID device, an HID, human interface device, hid device, 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 I guess is what I'm saying there. And you can talk to it over serial. So you plug it into your computer, your app can talk to it, and then it can talk back to your computer. Pretty cool. So over the single port, you'd plug it in, and you would then actually be able to communicate to it. So our little single diagram extended from there. Same deal. Alexa tell the Warzone controller to shoot. Goes to the API, goes to SignalR, goes to the UWP app. UWP app goes, hey, I've got a serial connection to this device down here, and it sends a bunch of strings over serial. I'll show you a little bit about what that looks like. And then it goes and sends actual keyboard and mouse stuff. And we got it to work. First warning of video game violence. So I'm sitting here. Oh, I'm not getting audio here. I don't know if it's a me problem. Just imagine me being like, Alexa, tell the Warzone controller to shoot. That's like the real delay, actually. That's pretty good timing.
Okay, chat, we need you guys to get one headshot. That way we can at least get the highlight. So someone's got to start shooting. Take a shot. Take a shot. There it is. Oh!
So, okay, there's something there. Pretty outlandish to be speaking to an Echo puck on my desk. So I thought about, well, if there's something here, and I had my brother come over and try it and use it in different games, and I was like, man, like playing without being entirely dependent on your fingers, on a controller, or on keyboard and mouse, like there's something really to be explored there. So we jump into sort of scaling out like super dirty prototype into something I called Suave Keys. It's all on GitHub. You can check out this stuff. Super early prototypes we were doing, competing in hackathons, which is super fun. So let's talk about what we needed to scale. For those that caught the SignalR send to all clients, that's probably the first thing, right? We need to actually support more users, more types of devices, more voice assistant services, more desktop clients, and also more games so that it's not just telling the Warzone controller to do stuff. And also, I don't want to say that. So for the voice assistant side, used Voicify just to be able to like, build it in one place, ship it everywhere else. And then on the client side, using .NET MAUI. So being able to, in this case, .NET 7, .NET 8 should be coming out soon, but basically building a single app for both the input clients, so you could use a Android phone or an iOS device, use that as an input, as well as then talk to the UWP client or the Windows client that was running under the hood. So the first thing we need to do is actually set up for multiple users, which means we need to authenticate, because we're talking about multiple devices. We've got an Echo speaker, as ridiculous as that is, or other iPhones and Android phones, and then on the other side, we've got the actual Windows client. We need to know you're the same person on both sides. So we need to authenticate anything coming from the voice assistant service and actually going back out. So on the app side, super easy setup with, at this time, at the point where I was building it back in like 2020, it was like the Xamarin community toolkit where they have like the built-in authenticator stuff. Basically, it's like if you're doing OAuth, you can kind of just like do the OAuth please code, and it does it, which is pretty great. And then on the voice assistant side, it's harder. So has anyone built an Alexa skill, by the way, or like a Google action, which are now also fully sunset? Okay, so let me explain this a little bit. When you go and you sign into a custom skill, first of all, you have to like enable it in your account. And then there's a button in the actual Alexa app that says like, okay, link your account. It then actually opens up the web page to the custom service. That then does some of the OAuth goodness. You end up getting an access token being spit out. You then need to teach Alexa how to take that access token and submit it on every request to that endpoint that we had set up before. Then you need to actually authenticate that and hand it back. So there's this weird, like, we're doing 3 different services, right? And some of it's not in our control. Ultimately, it ends up being just like fill out a form and make sure you can handle access tokens properly, which basically looks like this. In .NET, we can add bearer authentication pretty easily. As long as we know how we're signing our tokens, and we can create the UI to actually do the login, then we can actually handle authorization endpoints. So we just throw the authorized tag on anything. And as long as we've got our configuration set up with our encoding secret for how we encode the actual tokens, basically we're good to go. I'm not going to go through sort of line by line here. And then on the client side, all we have to do is call that web authenticator API from the .NET MAUI group or Xamarin back in the day, which basically sends, hey, go take the URL of our server, do the sign in, here's my client ID, here's my client secret in this case because it's dirty, and it does the actual UI. You literally just await it, and then you get a token back, or you get errors if something goes wrong. And then with the with the client code that comes back, you then go exchange it for a token. So now we've got a token, we've got a refresh token and an access token. We're logged in, and we can submit that with every other request, including to SignalR. So now we need to actually handle different inputs. So I built this really, oh, you can't even really see this because it was bad UI even when I built it. Wow, look at that. What you're missing is like the super cool like new wave of gradients that make it look like it's a physical button. But basically you could map a voice command to any different input. You could also set up macros. You could also do action queuing. So I could say jump, jump, jump in a panic, and it would actually go try to hit the space bar 3 times. And then we would do that still all over an Arduino. So you had to have an Arduino device, which is, again, silly, but it was necessary. And essentially what we did on the client side is we would find our device over the serial port that we found, and we would just write strings to it. If you haven't done serial communication, it's literally just sending strings over a cable, and you have to interpret it on one side versus the other. So in this case, we're telling it to press, and we're telling it what key to press. And we're also telling it for how long we want it to hold that key, which is basically this entire line here. And so we just write that string using a data writer over that current connection that we have through serial over that cable. So for example, if I wanted to press space, you'd see this string here, just like press space 500. Hold the space bar for 500 milliseconds. Super straightforward. So, come on. There we go. On the consuming side in Arduino, we then need to actually handle when we get a serial command. So the sort of breakdown is again, that press space 500 sample. The command is press, it's the first thing. The separator between each of the arguments is just a space. And then we need to actually interpret each of the subsequent arguments, right? So we have press, we're in the press something, we're gonna press a key, go figure out what the key is, have a gigantic switch statement or a whole bunch of if-elses in order to actually map it. In this case, you can see like, if we actually get space, then press the space, because space is also the separator, so we couldn't say press and then like 2 empty spaces, otherwise it breaks. And then hold it for that amount of time, and then release it. So, send stuff over the strings, over serial, get the actual press whatever. Okay, we've got space. Tell the keyboard to do that over USB. We're now pressing the space bar, hold for the 500 milliseconds, and then release it, which is cool. So now we need to prove that it actually worked. We had the ability to sign someone in to something like Alexa, or to any other service, because it's OAuth, and we could just ship clients wherever we wanted to. We could sign in on the UWP side. We could connect over serial to an Arduino running our code, and then that could communicate back and forth over all these sort of distributed channels. So I mentioned earlier competing in hackathons. Anyone done like a DevPost hackathon? Yeah, Mish has done some. If you haven't, and you're like, man, I want to go on a vacation, and I'm a really good developer, you could just like go win like $20,000, which is pretty cool. So there's big like cash prize hackathons, stuff like that. So we did one with Microsoft Azure Hack for Accessibility and the AI hack. So we introduced a couple things to the platform. One is using Azure Cognitive Services to start to recognize different face inputs. So we would take your camera in that same UWP app, stream your camera stream to the face recognition API, and basically say, like, are you smiling? If yes, then that's a space bar. So send the space command to everything else, but also all the same voice assistants that we can interact with too, which is pretty cool. So here's a quick video of viewing it in Sekiro. It's going to run for a little bit, where we have Twitch chat, we've got my face, and we've got voice too.
Our new game +4. Attack.
So fast.
There we
Wow.
go. Oof. Block. Ooh, attack. Attack. Ooh, that was actually done in time. Attack. Attack. Attack.
Yeah, speech recognition is super easy, guys. Also, so a couple of things. One, we were no longer doing it through Alexa, which means we cut out Alexa, tell the Sekiro controller to. That's like so many words that we don't have to say. We can just yell attack over and over again. Problem is we're still streaming the audio to a platform on the internet in order to actually do the recognition. So all the delay is like go send audio, get response back, validate the input is one of the words that we have in our little keyboard map, and then go send that sort of through the event loop to eventually get to an Arduino to like click on the mouse. Which is cool. We also did this really interesting, and to this day, this is the hackiest, just biggest pile of garbage I've ever built. So bear with me while I explain it. But this is using Snapchat. Anyone here a Snapchat user? I don't even know if it's really even popular out here. A couple people? Okay, so those who don't know, Snapchat's a social media app. slash camera thing. Basically, you take pictures, you put on really cool filters. They call them lenses. But as developers, you can also build lenses. So this hackathon was put on to get people to actually implement new custom lenses. You can do things like put an anime filter on yourself, or put a funny hat on your head, and it'll track your head, and all sorts of fun stuff. But we did something pretty interesting. Me and like the 5 people in chat, super cool, where we added more apps. So same exact system still exists. There's still like the crappy UWP app. You still have an Arduino plugged in, which is communicating over serial. You've still got all the SignalR goodness talking over WebSockets. But now we introduce a new Android app that has just a button that opens the Snapchat app, specifically with this custom lens. Then we've got this custom lens that tracks your face and different hand gestures. You can do like bull horns, finger in the air. You can raise your eyebrows, you could smile, and it would just show QR codes on the screen whenever that happened, because we can't like send data out of Snapchat, thank God. Otherwise, like everyone's privacy would be destroyed. So we have another app called the Snap Reader. So you now have to plug in, okay, hold on, bear with me. You have to plug in an Arduino into the computer over USB. You, second, have to buy more USB ports for your computer so that you can then plug your phone in that's running Snapchat into the same computer over a different USB port. And then the Snap Reader would be like, oh, you want to share your screen? Which screen do you want to share? And you have to select your phone because we're able to see the phone screen. And then we use a library called Zebra Crossing or ZXing, which scans like barcodes and QR codes. And basically, like the whole app is just like watching your stream of your phone and being like, where's the QR code? And so whenever you did something, it would find a QR code, and then it would go and talk to the actual service. So you also had to like sign into that app with that like same account that you made. So you're now signing in like 3 places, but what you can do is use Snapchat to play games, which kind of, you might be hard to see over here on this little screen. It's my face with a cool like alien filter, so I've got a bigger head than I already do in real life, plus my actual stream with anime filter on. And then there's these 2 QR codes over here that flash. So every time I do like a hand gesture, or if I raise my eyebrows, it's an input. Plus I can use voice at the same time, which is pretty cool.
I have to keep my coffee down here so I don't have to use my hands. So I'll be like,
for those on this side who aren't seeing my face, you're really missing out. I'm sorry.
I gotta like, I'm gonna end up like doing like this and like punching my coffee. All right, we're playing one-handed. So I'm gonna keep my other hand here so I can just be like, real quick. Just to see if it's working, I'm gonna use my eyebrows. Little jump.
I got really good at the eyebrow movement. So much practice.
There's the jump dive. All right, we're off and running.
Didn't make me better at games, but
double jump. Please.
It's just me falling behind, don't worry, guys. Okay, one more thing that we did. We built an integration with Twitch. So another app that you had to run on your computer while you're streaming, and you would sign into that Windows app. I was on like a UWP kick. I don't know. I was just like, everything could be a Windows app if you really want it to. And then you could specify the commands that people could type in chat. So in this case, it would be like exclamation point press key, or press like the same as a voice command. And it would send that actual command over to the API, which again goes all the way through to the Arduino and up. Super dangerous if you have a really ridiculous chat that's just spamming, pressing commands, and you've got your computer running and connected to the internet. But what it did end up doing, over there on the right side, there's a live sort of feed of the different chat, and you can see all the people saying exclamation point, press this, press that. Plus, we're using the Snapchat over here. Plus, I'm still using my own voice, and I can still use any other physical input device that I want, all at the same time.
Someone give me a no scope. How's the delay on chat now? Mouth open, reload. Jump. Just a little. Come on. Oh, here we go.
Okay, I saved you from the violence, but chat was going to get them. Okay, so that was really something there. I've got my face, I've got my hands, I've got my voice, I've got head movement, I've got all these different facets that I can use. It's just super slow sometimes. One, Twitch chat's super slow just because of the old protocol they use, and everything else is still being streamed over the internet, so it's pretty slow. So I wanted to sort of take a step back and have some people try this out. Worked with a few different groups of people working with people with disabilities, specifically in gaming. Groups like Able Gamers in the US, Special Effect out of the UK. Amazing folks to try just like these grossest prototypes where I was like, okay, we got to hop on a Zoom call here because I got to explain these 7 apps you got to install. Also, you have to have Snapchat, so make sure you set up a Snapchat account. and then you need 2 USB cables, and then I'll ship you an Arduino device, and then you can try it out. But people actually like found value in it. They started playing different games with it. My brother started using it to play every game, and so I wanted to step it up and introduce enabled play, which is actually what has now evolved into Cephalable, which is what I do full time. So going from something that's a prototype into real production readiness, when we're talking about like using Snapchat and crappy hardware devices and streaming your camera feed and your audio feed to the internet, means that we have challenges with a few things. Performance, like you saw, where in Sekiro I was like, attack, and I was like, wait for it, and then attack. Privacy, because again, your face and voice that you're putting in your living room or in your office are just going to the internet for some other place to store and process. Price, so fun fact, I did calculations as people were starting to use the existing like hacky stuff with using Azure. I also had a version we were doing with AWS too. If I wanted to run this for like 10,000 people using it like, you know, a few hours a month, and just constantly streaming their face and constantly streaming their audio, and never mind the rest of the hosted services, it was going to run me a bill of like $30,000 a month, which, you know, it's kind of hard to like go sell a little Arduino device and be like, hey, you know, pay me $10,000 for it, please. And also just scale, like scaling the actual services and having to, again, go out and sell devices. So let's talk a little bit about some of the key pieces. Speech recognition, super amazing. There's been a ton of innovation in different forms of speech recognition. Anyone use like OpenAI Whisper, anything like that? So yeah, some of the new stuff that's come out. There's a big difference in terms of accuracy trade-off and performance trade-off when we're talking about standard ASR approaches or streaming ASR approaches versus also like offline and edge approaches. So the general process, for those who haven't done speech recognition, is we start to record audio. That can start because you press a button. That can start because the app has spun up. That could also start because we hear a volume change difference enough. Like we're already listening to audio, but we're not actually like recording anything yet until like the volume reaches a certain point. But then we need to actually start to listen and record that audio somewhere and detect that you have stopped speaking. So usually you have like a threshold for like 500 milliseconds is actually pretty typical across all these services, where you're just dumping audio buffers over the internet. Usually it's over a WebSocket connection. Sometimes it's just over HTTP if you just upload the whole audio file. And then you sit there and wait after the end of speech to actually take that information, that data, and process it. That's why we saw the slowness of attack. Okay, the speech is done, let's do it, which was pretty atrocious. So instead, we switched to a different approach for speech recognition, this sort of predictive automatic speech recognition that's just constantly thinking based off of your speech pattern. I won't get into all the details about how we do that with like a graph neural net, which is pretty cool. But basically, the difference is audio is always on. Whether you're using it on a hardware device or if you're using it through the software, we're constantly having your microphone on, but we're not streaming it to the internet. We're actually running all the processing on the edge. So we can listen and record audio just like we always do, but we're processing partial speech. So as you're continuously talking, we're always looking at what is the next buffer that's coming out of it and what did we predict. But then we're also taking that based off of your past patterns on that specific device, and we're also looking at what are you trying to say or typically saying here. So in situations where you're like, shoot and reload, and you're saying that all the time in Call of Duty, we'll, over time, get to hitting that reload prediction faster, which is pretty cool. But also, we just dump the audio stream. So we're really only ever holding on to like 2 seconds at most of the audio stream, super low memory usage, no internet required, running it all offline, which gave us performance like this. You're probably like 1.5 seconds. Yeah, right. I literally sat here for 5 seconds while waiting for it to actually swing the sword. The fastest I ever got it on gigabit internet with nothing else on my home and streaming from a single device was 1.5 seconds to hit the sort of like jump, 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 cue things up, see the spacebar get hit 3 times. With the predictive side, we're actually getting that within 30 milliseconds, which is often faster than most people actually hit the spacebar 3 times in a row, which is pretty cool. So also, let's talk about privacy. I've mentioned this a few times, but basically like we got to take your audio and we got to send it to someone. So someone else is recording that, or you pay a lot so that they don't record it and use it, which is also, again, sort of on the pricing side. So offline, again, it never leaves your device. You can also just use it offline. You don't have to have an internet connection. It's just running in the app, still talking to the Arduino, but, you know, to each their own with how they want to handle inputs for games. So we also introduced different expression controls, so using your camera to detect expressions. Excuse me. I mentioned earlier in one of the hackathons, we use Azure Cognitive Services for the computer vision APIs to detect if you were smiling or not. Super cool. Streaming your video, which is even slower than streaming your audio. Then we had Snapchat. Really cool thing about Snapchat, all of the computer vision processing that some of you over here were not seeing behind me is actually done entirely offline within the Snapchat client. Your face, it's definitely streamed somewhere because it's a social media app, but the processing of the actual model is done entirely on the edge. And actually, as developers, you can even bring your own computer vision models to it as long as they fit within a certain format that's unique to Snapchat. It's a whole thing. But basically, for online expression detection, we were taking your video stream and then either streaming every single buffer of the video. So think of it like a camera streaming at like 30 frames per second. We're taking that, we're sending it to the cloud, and the cloud is giving us stuff back over time. Well, that got really, really expensive and slow. So instead, it's like every 200 milliseconds, I made up a number. We're going to send whatever that current buffer is up and then get it back, but still super slow. So instead, we do it offline, where we take that same video stream, we only hold a handful of buffers in place. So if we're running at 30 frames per second, we'll have like 10. So you've got basically like 300 milliseconds worth of data to work with, and then we can compare your movements, your face detection, and everything else like that, and we'll get into a live coding example of how we do that. So through the platform now, a lot more succinct, not a whole lot of different things going on. You have an app, you can still use a hardware device, it still talks over USB HID, and there's a shared service which also allows third-party devices and services like the Twitch bot, or if you really want to revive the Snapchat version, to do that. So just like we had in the prototype though, we're able to still communicate over SignalR, which is really cool. So in this case now, for something like telling the device to start listening, whichever the device is that you're using the microphone for. If it's like one of these physical boxes that we used to sell that have far-field microphones built in, or if it's the actual like Windows machine or the Mac itself that you're running on, we tell it to start listening, and we actually detect the devices that are registered to your account for your user, and we talk to SignalR for specific users, not sending it to everyone. And then when we receive that, or actually send that, we actually just send it over a post from the client side. So an app still using Xamarin or using a Windows client or whatever just sends a post for the specific device, authenticates the user, tells that specific device to start listening. And then in the Python side, on the physical devices, basically we do the same thing. We connect to the same SignalR host. We actually then receive the different events, and we tell our speech recognition to start, or we tell it to stop whenever we get information. So then we tell it on the way back, hey, I have started listening, which then also communicates back to the user by finding the user that this device belongs to and broadcasting to any client device that's online, which means if you have the Windows app and the mobile app and they're both connected to the same user, one taps to start listening, it updates everywhere in real time. But now we can sort of run this distributed model, which leads to situations like this. This is Jackson. He's one of our younger users and beta testers. He's 7. He lives with AFM, so he's paralyzed from the shoulders down. And his friends just started playing Roblox. And so he reached out because he wanted to try playing video games for the first time. He's never really been able to use a laptop before. It hasn't worked for him. He can't actually use a keyboard. And things like eye gaze devices don't work well for him. So instead what he has is our mobile app running face expressions. It's not Snapchat this time. We built our own. And then our Windows app client is running in the background. And he's playing this game that we're going to play a little bit later. That's just like an online browser game where you can click to lift the ball up. And basically, he's doing it instead with eyebrow raises, because he's able to move his eyebrows and he's able to tilt his head a little bit. So I'll let it run, hopefully get the audio.
Yay.
Good job.
Okay, wait, I'm going to let it play again. Catch his high score, because we're going to want to look at that later.
Good job.
Okay, he's got a high score of 10. I still haven't seen it that high. Some other use cases, Elden Ring, a.k.a. Big Dark Souls. So sort of bringing it full circle here. This is a video of me playing with voice and face controls, again, using the app to talk to it, although you can also use a webcam for your computer if you have one. And yeah, violence. Jeez. Sorry. There's a key moment in here called getting good, which for the Dark Souls players know what it means. For those who don't, it's that, which is timing a parry whenever you're getting attacked. And so this whole thing is practicing doing this hands-free. I'm actually using my head for movement, and then I'm flicking my head in order to parry. So basically doing combos using just my face and voice for movement. And also you'll see times where it's not perfect, and I don't quite get the timing right, because it's a learning experience to learn these new inputs. Like that, still trash.
Block. Mount. Run. Heavy. Heel. Heavy. Left heavy. Dismount.
Okay, but it's not just for games.
Open code.
I can also write code entirely with my voice in my speech recognition that's adapted to
Comment.
me using a mix of Cephible's voice
Type
controls
create
and
a
also
loop from
GitHub
1 to
Copilot.
100. Enter. Function. Tab. Enter. Comment. Type add a button to the page, and when the button is clicked, run the loop function. Enter. Function. Tab.
It's pretty great timing. They're not going to lie. We're just suddenly
Enter.
got the rest of the function.
Comment. Type run the add button function. Enter. Tab.
Okay. So there's two big aspects to this. One is how we actually set up controls and automation. Like how do I actually go about building something for Elden Ring versus Visual Studio Code? That can adapt to me over time. And then also the on-edge speech recognition and expression controls and the distributed controls as well. So we do things in an interesting way. We're using a new fine-tuned version actually of Llama 2 we built in partnership with Intel that allows you to basically describe the controls and your abilities to automatically create a set of control profiles. So we're not just doing the pre-prompting stuff that Scott mentioned. We actually have about 10 million different inputs and outputs and different apps and setups and the different controls that we generate that we actually feed to it in order to actually train that. And all of that is curated and managed by a team around the world, including about an 80% team with disabilities too. Then, when we have those controls, all the machine learning is happening on the edge. Our speech recognition, our expression controls, and everything else, without even necessarily having to use the phone too. So a quick version of basically how it works in the app to create these controls. You create a profile. You can type in the name of the actual app you want. In this case, I'm using PowerPoint, so let's make one for PowerPoint. Which input types you want to or are able to use, and then basically open text field, how do you want to describe how those controls should be used. So things like using voice commands for shortcuts when I'm editing my PowerPoint, and then I also want to be able to tilt my head left and right in order to go to the next and previous slides. And then basically I can also tell it things like, for example, some of our users have said things like, I can't pronounce the letter R, so don't use voice controls with R. And it generates it pretty beautifully. So then we can go and look at all the different things like, hey, you said next slide, or you tilt your head to the right. It's the same as the right arrow key in this case. Or you want to do copy or paste, or all these editing previews, editing controls that we have, like I basically asked it for. Once you have a control profile, then you can go and use your different controls. So we have our speech recognition little window at the top that's saying, basically showing you the speech as it's detecting it too, and can also support speech that is nonverbal. So if you're able to literally make a sound that is aural, then we can actually use that as an input. And we have different modes you can turn on for what we call optimistic speech recognition versus standard speech recognition. So one is like you can get the full actual text of what is said, and the other is, well, your control profile really only has like 50 words, so it's like totally crunch the vocab, and then constantly be looking for what word or control you're closer to. Again, adapting that to each individual over time as well. So I can say things like previous slide, next slide, and it jumps around. Expression controls, also another window that you can move around and resize, shows your face mesh and everything else that we detect, which I'll show you in a little bit. And I can do things like tilt my head left and right. You can even see with a very small movement versus what I was doing in Elden Ring where I was like, to parry. You can change that sensitivity to what works best for you, from the dramatic movements to the little sort of twitch movements. Or you can take virtual buttons from your phone, tap those in order to create these different shortcuts and inputs as well. So again, that concept that we saw all the way back from Snapchat over here to Twitch chat to my actual hands on a keyboard to using my voice, but this time super, super fast, predictive, and adapted to me as an individual. So all of this really becomes possible in order to combine all these things, all this edge machine learning that actually creates this value of both the inference side and the constant retraining. with Onyx. So for all of you who are like, hey, AI stuff, let's actually talk about machine learning. Woo, we're going to do it. So let's do some live demos and some live coding. We've got about 15 minutes left to show you a couple different things. Has anyone here used Onyx, the Open Neural Net Exchange? Onyx models, anything like that? Some of you are about to be like, wait, I can like do machine learning and I don't even have to like know everything. It's pretty awesome. All right. I have to end slideshow. We're going to switch over to Visual Studio. So I've got an app here that I call Face Test, which has models that I've trained to recognize different labeled face features. Things like different dots on my eyebrows, on my head, on my face, where my eyes are pointing to, the angle of my head, and things like that. And basically, we, in this demo, are taking a whole list of images that are just in a folder, and then we're going to run the recognition, draw the points on their face, and then actually sort of run it back into another folder. So if I go scroll down ever so slowly, you can see where we actually are loading our files directory, the path where we want to put the results. So basically, same thing. We're pulling from /images. We're dumping the outputs into /results. We initialize this face detector. I'll go into that, what that actually looks like, plus our face landmarks detector. And then we're initializing a painter. And then basically for each of the files that we're going to pull in, we forward the actual low-level bitmap to it. And that then outputs basically a face. So it's going to be a actual like, hey, here within the image is the actual face, a face box, if you will. And then we take that face box and we run it to the landmark model, which then, so here, we crop our face. Then we forward it to the other model. And then this gives us just a giant list of XY coordinate points within the shape of that image. And so we take all those XY points and we paint a dot for each one. So what I'm going to do is take a new image and actually show it to you live what it outputs. Cool, it's looking at the black podium. That's me. Wow, I look good. Gorgeous. Okay, now if we go run our face test, there's other images in here, so it's going to sort of step through them. So we've got 11 different images. We're processing these, including all the other times that I've run this. Oh, I actually need to move the image into that folder, don't I? That'd be good. We're going to go to wherever my picture went. Camera roll. That's me. Wait, that's not, this is the new me. And then we're going to go find our face test project. No. Where's my face test? Stand by. And then we're going to do it this way. Oh yeah, thank you. It's weird it didn't save it as a C# file. It's wild. All right, now I'll run it again, and then we should be able to go see the output over here in our results, which are not going to be pulled in. There it is. Boop. And I'm going to zoom in because it's a high definition camera. There's these little red dots along my eyebrow, along my eyes as I peer deeper into your soul. Ever deeper. But everything around my face, my eyebrows, little dots around my eyes. But what's really cool is we can take that low-level data and start to monitor your different changes over time, too. So things like eyebrow raises are as simple as, well, your eyebrows were down here relative to the rest of your face, and now they're up here relative to the rest of your face. So you've raised your eyebrows. Let's go do something with it. So let me show you what it actually sort of looks like in real time in the actual app. Or I got to kill the camera because Windows only lets me use the camera for one thing at a time. Where we've got this basketball game that Jackson had just been previously playing. And so I can do things like go down here and click Start Expression Controls, and it opens up my little window and should be pointing right at my face. Oh, I'm going to end up unplugging myself over here. Come on, conference Wi-Fi. In the meantime, let's load in Tap Tap Shop. And we're going to mute that because that's going to be atrocious. Come on, tap, tap shots. You can do it. I see my camera. There it goes. So all of my little face detection. I've got my baseline face and the little blue one that you can see that it's being measured off of. We're going to full screen this game. And then I've got mouth open as my input for raising the basketball up. Oh no, I'm not nearly as good as Jackson. Oh! Guys, stop laughing. No. Okay, my high score is 8, guys. Stop. So yeah, I still have not bested Jackson in his play style, but let's go look a little bit more sort of what these models look like, and also some of the other tools that are at your disposal for training your own models. Because Onyx isn't just for face recognition. You can train models based off of basically anything. One of my favorite apps to use, if it's going to actually open for me, is called Liner. Super easy to get started if you're not familiar with training machine learning models, but you have the ability to load in a bunch of data, or you can download like a pre-built data set from really anywhere on the internet if you have a license to it. Come on, Windows. Hello. Let's try it over here. Why aren't you finding Liner? I'm going to literally just go download it. You'd imagine an app called Liner has a whole lot of different things, and this literally isn't even the one I'm looking for. If this isn't it, then I'm going to have to go show you how to do it all in Visual Studio and not share any third-party tools with you at all. It's just not. Windows is giving me some grief. Okay, well, some other cool things you can do. Where's my ML toolkit? Is it just Windows search giving me grief? Okay, I'm just going to... Guys, it's fine. Trust the WinML toolkit. I know it's old, but we're going to open a model to look at it anyway. So this is sort of the other side for actually inspecting models. I'm going to go in and, for example, grab the face detector model I have or the landmarks detection model. Really cool thing about the toolkit app is it actually sort of can dissect the different stages in your model. It doesn't give you a great way if it's like an actually compiled Onyx model to do editing. But it does actually give you some information around like, hey, I downloaded this mysterious Onyx model from GitHub, and I actually don't know what I'm supposed to be doing with it or what it's doing. Especially with computer vision, where there's usually like very specific constraints around the images that you can use. This will give you an idea basically of the different dimensions, shapes, and strides of the actual buffer or bitmap that you need to pass it. And then essentially what it does with it in terms of batching. So great way to sort of debug, but I really wanted to, oh, wait, it did open. Guys, it's just slow. Oh, it's installing an update. Okay. Well, you'll have to imagine that Liner is a really cool app where you can go upload a whole bunch of data, label it, and then output an Onyx model, which then you can bring to basically any of your apps. Another important thing to note about Onyx, too, is although I'm using it in .NET because I'm just a .NET kind of guy, it has runtimes for basically everything. So if you're a Python developer, great. If you want to run it in the browser with JavaScript or with WebAssembly, there are ways to do that too. As an example, actually, the actual several face expressions, this is an Electron app. So like I'm running this in a worker process with Node behind the scenes. And basically the rendering side is just dumping that information to the worker process. So basically run it anywhere, use it anywhere, build models super easily, whether it's within Visual Studio, within any online tool, or a tool like Liner, where I can go create a new project, do like audio classification if I want to do like, is my dog barking or is it just my feet? Or this is, for example, where I do some playground stuff with different hand detection and movements and stuff like that as well. So you can import data, you can download from public data sets. So here's a great yoga pose data set. Nah, we're not going to do that. We're going to do dogs versus cats. I don't want to get in trouble with like if they have weird yoga pose images. Cool. So it's literally it's like the is it a hot dog thing that Scott Hanselman mentioned. But it's like is it a cat or is it a dog? With just like a couple labeled pieces of data. And so then you can take that information and you can go to train it, and it all runs and trains on your local machine. If you have a GPU, great. It should be able to train faster. If you don't, sit and wait. I've been thinking about doing a talk where I'm like, all right, we're going to actually do like a Llama 2 training session with like 10 million records, and like the whole hour is just watching it train. Look at that. It's almost done, guys. Validating all of its accuracy. And then, when it's done, you can just export it to Onyx or to TensorFlow or TensorFlow Lite or Python or Keras, just literally whatever you want, and then it'll literally just spit out. I'm going to throw this on my desktop. Cat or dog.onyx. And then we watch another loader. So pretty cool stuff. A lot of tools at your disposal, basically, to get up and running with building these different things out. We're going to play from here. There we go. The main thing I sort of want to help you get out of this is there's a lot of tools out there for demystifying things like machine learning. There's a lot of different ways to apply this as well. Onyx is one that I personally love just because of the flexibility. You can run it at massive scale on the server. You can also run the runtime on basically any client. I've got Raspberry Pis that do image recognition for my home security that I built super easily. Train the model with Liner, dump it on a Raspberry Pi, throw a camera on it, and you're good to go. But really that we have these tools and we can use them to solve real problems. In my case, I like to focus in making games accessible and making education more accessible. But really there's plenty of problems out there to solve. So thank you for coming to learn a little bit about the wild story of how we got here to building these different types of inputs and controls, and a little bit of Arduino, C#, and how many apps you could possibly fit into a single project. So thanks, everyone. Those who like links, all the GitHub stuff you can just get from my /Suave Pirate too. So if you want to go use Snapchat, man, go for it. The Cephable app will actually be public to download in Europe, assuming next week, actually. So if you ever want to try just face controls directly, you don't want to have to run something yourself or plug in a whole bunch of stuff, you'll be able to try that. It's totally free. Because, again, I'm not paying $30,000 to the cloud to stream your video. So.